Hi dear students, in the very first introductory lecture, we were discussing about the chemical reactions and equations. So I was telling you about some of the indications by which we can say whether a chemical reaction has taken place or not. So for example, if a substance undergoes any change in color, it may be a chemical change. For example, you see here a leaf getting its color changed from green to its brown. Okay, so you cannot convert that back into the green color. It would shed in autumn. Okay. Next, if there is evolution of gas, it may be a chemical change. Okay. For example, when zinc reacts with hydrochloric acid, hydrogen gas is evolved because it leads to the formation of a salt that's called as zinc chloride. Okay, so that's a chemical change. Now we can see that in some chemical reactions there may occur a change in temperature. On the basis of this, we will be studying two types of reactions. One is endothermic reaction, another is exothermic reaction. Endothermic reactions are those reactions which occur with the absorption of heat. Okay, for example, if you want to decompose limestone, okay, marble, shall it decompose of its own? No. The formula of limestone is calcium carbonate, CaCO3. If you heat it strongly, it would get converted into calcium oxide and carbon dioxide. So the decomposition of calcium carbonate is an endothermic reaction. Okay. There are also some other reactions where heat energy is evolved. We can call those reactions as exothermic reactions. For example, if we mix acid, okay, and base, neutralization reaction, it leads to the formation of salt and water, and heat energy is liberated. Okay, so many combination reactions are there where two or more than two substances combine to form a single product. They are usually exothermic reactions. You understand? Thank you. Next is if we have a formation of precipitate. Okay, there are some reactions where you mix two reactants. There are two solutions, different solutions, two different compounds you combine, and you get a substance which is insoluble in water. We call such substances as precipitates. Okay, we will be discussing in the second half of this chapter. There are four different types of reactions we will be discussing: combination reactions, decomposition reactions, and displacement and double displacement reactions. Okay, the double displacement reactions are also called as precipitation reactions. We will be giving examples about precipitation reactions also in the second half of this chapter, maybe in a second or third lecture it would be. So if now again you see here, I have indicated, I have given an illustration in a diagram where you see two test tubes, glass test tubes are there. They contain clear solution. Okay, but when you mix those, you see the cloudiness being formed in the third test tube. It's because of the formation of an insoluble substance that's called as precipitate. Now we can define what's a chemical equation. Actually, whatever is happening, for example, you are mixing two different types of salts, you get a third different compound. These reactions are usually happening in the solutions. Okay. Now, if I want to depict this pictorially to a student, I want to explain him what has happened there. How you can show it? You can show it in terms of either word equation. You can write that this substance has reacted and this product has formed. But nowadays, word equation means, for example, I write, suppose if I combine hydrogen and oxygen, it leads to the formation of water. I can write hydrogen as HYDROGEN. I can write oxygen as OXYGEN. And I can write gives GIVS water, WATER. So it makes it a very lengthy procedure. Okay. In chemistry nowadays, we don't need to write hydrogen as HYDROGEN. We write its molecular formula. Okay. We know hydrogen is represented as H2 in nature because single hydrogen is unstable. H2 is very much stable. It combines with oxygen. Suppose oxygen has the molecular formula of O2. Okay, because single oxygen does not exist in nature, it is because of the instability. Okay, you might have understood already the concept of valency, or we will be discussing in coming lectures. So likewise, you see here magnesium, when it is burnt in air, magnesium is a metal. If we take a magnesium ribbon, okay, a thin metal foil of magnesium, you just burn it in air, it would catch fire. Okay, now what is the end product when a substance burns? Obviously ash is formed. Okay, so that ash formed, that here in case of magnesium, that's actually magnesium oxide. Magnesium oxide. How that magnesium oxide is actually formed? Because magnesium has reacted with oxygen of the air, and it has led to the formation of what? Magnesium oxide, and lot of heat energy is liberated because it catches fire. Okay, now if I want to write, this is the word equation. If this is the word equation, I wrote here magnesium plus oxygen, means plus here means combines. Magnesium combines with oxygen is equal to magnesium oxide. It means it gives. So if I write a reaction or a chemical change in terms of words, okay, the substances you have mentioned on the left, they are called as reactants, and the substances you are mentioning on the right, they are called as products. Now this is too lengthy. Nowadays I can represent magnesium in terms of its symbol. Symbol is the shorthand representation of an element. Magnesium can be written as Mg, capital M, small g. I can write oxygen as O2 because it is the stable form of oxygen. It gives, I can show arrow. Okay, magnesium oxide, it can be written as MgO. Okay, so that if I write it in terms of symbols, you can call that as skeletal equation. Okay, that's called as a skeletal equation. Now I am showing it here. A chemical equation is the symbolic representation of a chemical reaction in terms of symbols and formulae. The substances that undergo chemical change in the reaction, for example magnesium and oxygen are the reactants. Okay, the new substances that are formed during the reaction are called as products. Okay, now what's a chemical change? A chemical change is that change in which new substances are formed. The combining substances have lost their identity. Okay, so what's a word equation? A word equation shows the change of reactants to products through an arrow placed between them. Okay, as I told that those substances which are combining are called as reactants, whereas those substances which are formed are called as products. The reactants are written on the left hand side, and with a plus sign between them. Plus sign indicates that they combine, whereas the products are written on the right hand side. Okay, if more than one product are formed, you separate the products with plus sign. Suppose if a reaction involves heat energy, that's always shown above the arrow. If some temperature, pressure, okay, or a catalyst is required. Catalyst is any substance with which a reaction increase its speed. Okay, a catalyst increase the rate of a reaction, it increase the speed of a reaction. For example, I can tell you, when we eat food, okay, it undergoes digestion and we get energy. Carbon dioxide, it's converted into energy. Oxygen is liberated, okay, during digestion. So actually that reaction that takes place, that's a chemical change. So in that reaction the heat energy is evolved. Okay, now skeletal equation. Skeletal equations are those equations which show the reactants and products so formed without balancing them. For example, if I write Mg plus O2 gives MgO, it means magnesium combines with oxygen to form magnesium oxide. Okay, now if you see here, on left hand side I have written one magnesium atom, on right hand side I have also mentioned one magnesium atom. On left hand side I have mentioned two oxygen atoms, whereas on the right hand side I have mentioned only one oxygen atom. Now there is a law which states that, that's law of conservation of mass. You might have heard about it. This law states that mass of the reactants should always be equal to mass of products. It's also called as law of conservation of matter. That's matter can neither be created nor be destroyed. You can convert it from one form to the another form. So that means total mass of reactants should be equal to the total mass of products. Okay. So for that reason, you need to balance a reaction. For example, I have shown here a balance. Here the two pans are not balanced. Okay. If you want to balance it, you have to make the weight equal on either side. So such an unbalanced reaction is called as skeletal equation. Okay, a reaction which has not equal number of atoms on either side, that's either side of the arrow, on the left hand side, on the right, and the right hand side, that's called as skeletal equation. Another example I had mentioned here, H plus O, H for hydrogen, O for oxygen, gives H2O, water. Okay, actually whenever I write a chemical reaction, I have to mention hydrogen as H2, we have to mention oxygen as O2. So we'll be discussing that later, because as I told you that hydrogen and oxygen, nitrogen, okay, these are called as diatomic species. Such elements such elements exist as molecules in nature. Okay, they are present as H2, O2 and N2 because they are stable when they combine with each other. Now balanced chemical equation. The chemical equation needs to be balanced so that it follows the law of conservation of mass. As I told you earlier, that mass of reactants should be equal to mass of products. If substances combine, they should not lose their mass. Okay, the mass of total mass combined should be equal to total mass of products. A balanced chemical equation occurs when the number of different atoms of the elements in the reactant is equal to the number of atoms on the product side. So total elements combining, total elements formed. Okay, new substances may be formed or are formed obviously, but the number of atoms should be same. So reactants gives products. This is a chemical change. How to balance a reaction? Okay, this would be our next lecture, how to balance a reaction. And I told you why should a reaction be balanced. It's because it should obey the law of conservation of mass. Mass can neither be created nor be destroyed. The total mass combining should be equal to total mass formed. So stay tuned, we will be discussing about how a reaction should be balanced. Okay, if you have any doubts, please let me know about it. Hope you understand very well, and I hope I would be able to keep your interest in this. Tell me also if you are happy with delivering the lecture in English or in Hindi or in both languages. Please let me know. Okay, thank you. Have a nice day.